Okay, thank you very much everybody for coming and picking this weirdly titled presentation. My name is Stefano, and during the day I teach game design and game studies at NHV University of Applied Science, and during the nights I tend to develop video games, and I did so for the past 16 years. I started with the Amiga 500 in 1996. I published a few point-and-click adventures in the past. You might have played them, maybe, if you were into this genre. I did some portings for GBA, worked on more point-and-click adventures, and worked on some games that, if you played them, you likely hated in the past. One of them is the last game that I delivered, which is called GUALENI, or The Horrendous Parade. And the reason why I'm talking about this game today is that it's the first casual game that was supported in its development by the use of medical technology. Before I get into the meat and bones of this presentation, so talking about how we use this technology to actually tune a game and prepare it to release, I'm going to give a small introduction to what the game is about, because I think that understanding the mechanics will help you understand how we actually tune them by means of biometrics. In order to do so, I will jump back 250 years to an essay published by David Hume. I think I'm in the wrong conference to talk about these kind of things, but I will still do it because I'm daring and I don't care. Okay, so this David Hume published an essay about the functioning of the human mind. And what he proposes is a vision according to which we can have simple ideas of things that we can have experience of. He makes the example of a horse. We can look at a horse, touch a horse, ride a horse, see how it moves, touch his hair, so on and so forth. By collecting these empirical data, we form the image of a horse in our mind. He calls it impression, which is a simple idea. Of course, we can have a simple idea of sand, sea, precisely because, yeah, those are things we can encounter in our experiential world. This is, of course, not restricted to the horse, but it can work very well for other animals, like the eagle, for example. So we can have a simple idea of a horse, a simple idea of an eagle, but we cannot have a simple idea of a Pegasus. The reason for that is that, well, as I just said, we cannot encounter this animal in the world we experience in our everyday life. However, we're capable of imagining a Pegasus, right? And this is precisely because, according to Hume, our imagination works in a way according to which we can combine qualities and aspects of our experiential world into something new. For example, in this case, you see it's a combination of the two beasts that I just mentioned. If you think about the merlion here in Singapore, same idea, right? Lion and mermaid or fish, and you get the same idea. So, as a derivation of this observation, according to David Hume, our mind is limited, or our imagination capabilities are limited by what we actually can experience. How did I use this idea for my video game? So it's important to notice first that my game takes place within a book. So all the game is within a book. What happens is that certain beasts, like bizarre beasts like the rhinoceros with the condor body, cross the illustrations of this book. In a way, we try to escape knowledge, right? And what the player must do as a sort of beginner taxonomist is to recognize the beast before this beast manages to escape knowledge. And the way to do it is to manipulate these two cubes. This is an iPad game only, right? So the player is asked to actually put the fingers and rotate and spin the cubes until the faces on the top of the cube match the beast. So the beast is correctly recognized. I'm going to show you a small trailer in order for the idea to actually be clearer, hopefully.
Torrid passions, gratuitous violence, mysterious butlers, none of them in GUALENI, a video game for the apple pie by iPad featuring a horrendous parade of paper beasts. Correctly categorize those fantastic specimens using their taxonomic cubes. Feed the brutes, keep them sated. GUALENI, an action puzzle video game like no other. Right, well off then. All that stuff about a bloody apple pie, I don't know what that was about, bloody nonsense.
Okay, should be done, okay. So, if you take an animal like this one, for example, it's a tiger head with 2 parts of a lobster. It is clear that, or rather I hope nobody here encountered this animal in their everyday life, right? But still we're able to take it apart and imagine and understand what it is precisely because at least a part of our mind functions according to what David Hume said. So in other words, what I've done is I created a game which uses that idea of David Hume, that understanding of the human mind as a game mechanic. As a consequence of what I've done just as an experimental gameplay, well, my claim, and that's actually part of my PhD research, is that we can use video games to explore philosophical concepts, explain them, making them interactive, come up with new philosophical problems, or give answers to philosophical problems. So this is all like what I just discussed. It's not particularly interesting for you, but at least now you understand the gameplay and the reasoning behind the gameplay. So I told you already, I think in the Rome conference, talk about these kind of things, and probably the only philosopher you care for is the Philosopher at the end. So now that you have an idea of how the game works, I would like to get to the actual topic of the presentation. How to use biometrics in the context of casual games to facilitate and aid the development. First of all, you might be wondering, all right, so the speech is entitled Biometric Design, but we don't perhaps know what is intended by biometrics. So I'm going to try to give you a very short overview of what the word means. In order to make you understand what biometrics is, I would like to reason by analogy, like presenting to you a case which you're more likely to be familiar with. For example, a lie detector that you might see, for example, in spy movies or old movies and so on and so forth. In a lie detector, what happens is that a subject is hooked up to a number of sensors which measure and track certain dimensions of, for example, your body functioning, such as, I don't know, the frequency of your heart, the frequency of your respiration, how much you're sweating, how dilated your pupils are, and so on and so forth. By observing these changes in the body of the subject, a researcher or an interrogator, whatever you want to call it, is capable of approximating and understanding something about the internal states of this subject, right? So we'll repeat it once again with different words. The fundamental belief at the base of biometrics is that internal states of an individual, for example, stress, emotional involvement, anger, etc., have physical ways of expressing themselves. Okay, clear? Another example might facilitate your understanding. If you've seen the movie Blade Runner based on Philip K. Dick's novel, you would know that the Inspector Deckard used this kind of biometric tool to verify, or rather test the pupil dilation to assess whether a subject was a robot or an android or a person. Our setup looks more like this. This is Marcello. He works in the university together with us. And you can see a bunch of sensors attached to his skin. For example, you have electromyograph sensors on his brow. Normally we also have 2 around the mouth as well. They actually detect the changes in electrical potential that actually stimulate the muscle. So even imperceptible frowning we can actually detect. He has a, what do you call it, the eye tracker and eye scanner, and a bunch of sensors on his fingers. Those sensors, at least these 2, are electrodes capable of actually noticing how the differential of electrical potential changes while with his sweating, and another one tests for blood pressure and heart frequency. I need to put out like a little note before I continue. I'm not the first one who tries to use these tools during the development of a video game. I mean, of course, these kind of tools were used for advertisement before, and in the context of game development, companies like Valve and EA use it quite often, right? Most of the researchers that also do games in the field of biometrics are from Valve. One thing must be observed, though, that both Valve and EA work on large, long-lasting projects, right? We've been talking, I mean, many presenters today talked about 4 weeks, 5 weeks development, scrums of a few days, those kind of things. This is not the kind of production setup that the companies that I mentioned have. On top of that, EA, especially EA Sports and Valve, work with games which tend to elicit very intense emotions, such as, again, rage, stress, in a way which is certainly more detectable than with the general casual game. Imagine like a puzzle game versus a first-person shooter. You immediately can tell the difference. I mean, is concentration as visible as, say, I don't know, pride or rage or anger or wish to pursue revenge and so on and so forth. So it was a challenge that we started together with the university to try to figure out if these same methodologies, maybe made faster and optimized, can be utilized in the simple and short development cycle of casual games. So the dilemma was, can biometrics support the development of casual video games and not only of high-intensity, long production cycle development? And of course, we can immediately see a number of pluses. So for example, in normal quality assurance, you would have, say, questionnaires during a certain play session of a certain length. You wouldn't be able, for example, as a tester, to remember how you felt at minute 2 of your gameplay when your interviewer is at minute 15, for example. It's objective, so you cannot lie to the way, for example, you can be biased towards certain developers, or you can actually try to sweeten the pill, as some other developers were mentioning. In this case, you cannot condition your body. Or if you're very good at conditioning your body, you cannot do it while also playing the game because it's too heavy on your brain functions. So nobody's actually capable of doing that. Those are considered to be objective measurements. Doesn't impede you from working with traditional QA methodologies, and offers certain insights which sometimes even escape the conscious knowledge of the subjects that are tested. In the cons, we have that it's expensive. The setup that we have now costs roughly 12,000 euros, which I don't know how much that is in probably 20,000 Singapore dollars. It's difficult to set up environments which actually do not pollute your data with noise. For example, a change in temperature in the room might lead to complete noise and destroy the results of a playing session. Change of lighting in a room, noise outside a room, the presence of electrical or magnetic field generated by lights like the ones that we have here might disrupt EEG or EMG results. So it's very difficult, and companies, such as small companies in particular, cannot actually set up a sterile lab environment. So this might be problematic as well. It requires at least a statistician to do data analysis on the stuff that you've done, and not many casual game companies have a statistician on staff. And at least in the case of casual video games, there's no existing literature on how to apply these methodologies to the quick cycles of casual game development. So we have a bit of a puzzle in our hand, not only because the game is a puzzle itself, but also because, yeah, how do we cope with all these pros and cons? Let me tell you how we've done it, because this was the pioneer of the research project that I just outlined. And currently it's still in development. It's going to be finishing in September. This was our pioneer project. So I explain you how we went on to trying testing this game out with biometric technologies. So imagine that I, as a designer, want to understand if my game is working. And the first thing that I'm looking at least the first thing that I wanted to look at, is as soon as the tutorial for the game is over, what is the correct speed for a basic beast, so a 2-module beast, right? How would I manage to make my players, as soon as they approach the game, you all know how an approach is important for casual games, how do I manage to make them feel that the effort is not trivially easy, and it's not overly punishing after you've just finished the tutorial? So you're an experienced player. How do I tailor-made it for you? So my first question would be, given my target audience, what is the optimal starting speed of the beast as soon as they finish the tutorial? So how can I hook people up with an experience which is not too easy but still rewarding and matching up to their expectations when they know nothing about the game or can just barely know how to twist the cubes, right? And so we set up the first experiment, which was a comparative experiment. So what is the optimal walking speed of the beast at the first impact with gameplay? In the game design, I set up the initial speed to be roughly 24 seconds. So it takes 24 seconds for a beast of 2 modules from coming into the page to abandoning the page, which means game over. I tested it with paper. So I made paper cubes, and a friend of mine was actually navigating the beast at 24. And I said, like, meh, this kind of works, right? So I leave it at that. It was mostly guesswork based on paper prototyping. And then I said, well, it's a comparative experiment, so let's try to give him something a bit easier. Let's add 25% just for the sake of it. Let's make a version of 30 seconds. And on top of that, let's make the testers play other games on the side of it that are going to be tested. We're not going to be telling them which one is the one that we tested. Actually, we tested all of them for comparison. And they were going to be exposed to a questionnaire at the end of the experience. We also have one of the testers here in the room. There's Ling over there. Target audience were women between 25 and 45, and so we tried to gather all this kind of target audience. She was exposed to 2 other games besides for the first version of this one, and a questionnaire at the end. Initially, our lab looked like this, more or less. This is one of our test subjects playing the first version of the game. We got some results. The general results, the way we read it, and we're not going to go into depth in this first test, is that according to the quality and the performance that the players recognized in the questionnaires and checking out the stress results, we figured out that the 30-second one was less stressful. And in general, by the answers that we received, it was more appreciated in terms of gameplay. So the first feedback we got is that, Stefano, the first 24 seconds that you envisage are too taxing for the first time you actually encounter the game. Maybe playing with paper cubes was easier than actually manipulating them on the iPad. Maybe they're not as fast as you are. Anyway, they said the 30 is better, but I noticed that compared to the other game that we tested, the excitement and stress levels were much higher. So the first change that I did is like, well, let's try with a version which is even slower than the 30. We also noticed that during game over, there were acute stress spikes. And I was like, as a designer, okay, in the next test I want to try to figure out what that means. So I will run another test similar to this one, and I will try to validate as low a speed as being the optimal speed. So I will try to see if these results and the satisfaction from the user align to the ones that I expect from a successful game. And I will try to figure out what those spikes during game over mean. As a game designer, you don't want those spikes to be spikes of anger and dissatisfaction. You want them to have a positive valence. You want to encourage them to play again and to feel that they were close to success rather than feel as punishment. Especially because I'm trying to develop a casual game, not a hardcore game in which punishment to an extent can be acceptable. So we ran the second test, and the objectives were once again to validate the initial speed, which was set at 31st second, just again, guesswork. I added 4 seconds and see if it works. Is the acceleration of the beast also something that works out? Because you need to understand, at least like in the trailer, you see that you can feed the beasts, and part of the reason why you want to feed the beast is that eventually they will start to pick up speed. They will start slow and they'll get up faster. It's a traditional arcade mechanic according to which you can actually shorten and keep the play session to a certain designed amount. So my idea was like, according to literature, most people don't have more than 20 minutes to play a casual game in a single session, because that's the average commuting time or the average time that a housewife has between coming back from work and starting to cook for the kids. At least that's what, for example, a book by Jesper Juhl, A Casual Revolution, is pointing out as optimal times. A reasonable bite chunk of gameplay at the beginning, and when you get an expert, you don't exceed 20 minutes. I was looking for something like that. And then again, what about those spikes that I mentioned? So we ran a second batch of tests with more people. This is the second version of the game. And we got nice, in this case I prepared nice graphs for you. And one of them in particular, I'm going to explore together with you, okay? This is a graph pertaining to the second version of the game, only focusing on skin conductance, which is one of the primary detectors of stress, okay? Let me show you how to read this. These are minutes. So this is a minute, 2 minutes, 3 minutes, okay? Every dot represents a beast. A blue dot is a beast with basic speed, so before an acceleration. A black dot is a game over beast, so a beast which you actually managed to escape. So we see that in this session we have 3 game overs, right? Can you follow? So this part of the graphs encapsulates what I just tried to do. As soon as the tutorial was done, we put these tests in a game, and let's see how it goes. We notice, to begin with, a high level of stress. You don't know what to expect from the game. You've been exposed to the tutorial, this is the first time you do it for real, so it is expected that they are a bit excited. But something that you see as the beasts are categorized, they actually find it, at least this is what the stress is saying, manageable. So beast after beast, the person is getting calmer. So I can cope with this effort right now. Then we have an acceleration, and a few seconds later, right, we have a game over, which is also validated by a certain raise in stress. This kind of sensor has a latency of 2 seconds. So when you start sweating, actually this picks it up as change in the current that passes between two electrodes 2 seconds or 3 seconds later. So first acceleration meant game over. And with game over came with a stress spike. Okay? This was one of the spikes I was telling you about. Let's see what happened next. Finished? Let's start a new game immediately after. This person goes even calmer with the 4 beasts, as if the actual tasks were getting easier, right? In a way, you see like the excitement when the beasts accelerate is not as steep as before. It's a bit steeper, but the person actually copes with the first 4 accelerated beasts. After 4 beasts, we have a further acceleration. You see it in a little spike and in the further game over, which is another, oh, wow, I was about to drop it, which was another spike, okay? So, cannot take the first acceleration, can take the first acceleration, but the second one already causes my death, and we have a spike. Third test, again, a decrease in excitement. In this case, the first acceleration is almost flat, okay? So that's kind of the optimum level of stress. They're not getting any more stress, they're not getting any more calm. That is perfectly what this player here, the third session, can take. Third acceleration, it goes higher. Fourth acceleration in this case calls game over. One thing that I'm happy with as a designer is that, well, it shows a definite improvement. By this third session, so 3 minutes into the game, you actually can have a 3-minute gameplay session, and essentially this was a good result. This is the same exact scheme seen from a Zygomaticus major point of view. So we figured out that, since I only have 1 minute, the people were actually smiling during game overs. During interviews, we actually figured out that the spike was actually perceived positively, not only by the smile, but by the fact that people felt that they're almost always close to get it. So, damn, it escaped to me, but it's okay, I'm almost there, right? In every case, it was perceived in that way. I should tell you something else about the spikes, but I have no time, so let me conclude. The speed was finally set at 36. The acceleration was smoothed a little in order to obtain, I mean, it was already good enough as far as the acceleration was concerned, but I decided to take it down a notch because my expectations were almost always too high with regards to my female players. No offense for you. The game was released in November last year and got very high critical reception. It got currently an 83% in Metacritic. Sales are not too good though. So in trying to boost the sales a little, we are developing a new game mode which is going to be released in 3 days, featuring human parts and a new game mode without time pressure. This is my record, and I hope I convinced you that at least some insights in the game were obtained just by the use of this kind of observation. And these observations, again, are objective. It doesn't take like an instinct of a designer to actually obtain this kind of information. If you manage to get interested in this topic, or if you manage to beat my score, which I hope not, you can Twitter it to me. I'm very happy if you have any questions for me or about our process, and yeah, please ask. I mean, I'm very happy. I mean, I'm trying to propose this as a possibility to develop casual games in a technological way. Yes?
Well, actually I have a few questions. It's great to have another member of the academia over here, so I'm very happy. But I have one question. Basically, you're using biometric to figure out if your game is fun or not, right? That's
actually, we do it during development, not when we release it. Okay.
That's actually a question, because basically I have a friend who is also a researcher who's doing something very similar, but instead of investing on expensive biometric, I understand that biometric can actually like get like connected the guy to see if they're excited, they're happy, or they're not. But one of the things which we actually use in the game industry is we can use, like, if suppose we're talking about web-based game, flash-based game, we can actually look at the pattern of the clicking and basically the mouse movement, and if the person logs in or logs out of the system quite well. And that actually is the kind of metric which we use in the social, the casual network area a lot. So how's your system better than these types of systems? And if you have to invest like 17,000, which we can only use in like a closed lab, and we cannot use like a beta test with a lot of people, how can this system be better? This is like a curiosity which I'd like to know about.
Okay, like your question is absolutely valid. So he's asking, in which way, I mean, can this be better than general metrics? Since we can have such a large amount of data and such precise data that, well, why do I need to spend thousands of dollars? Why do I need to have a lab and hire a statistician to get these things running? And in my opinion, like the question is very, very clear. One thing that you need to, I mean, remember or understand to begin with is that these two methods are not exclusive, right? Meaning that you can actually do both together. And my essential point is that you're talking about big companies that do metrics that only have a resonance when you are in the thousands of users and you already release the game. Whereas you can run this with a very small amount of users. You need roughly between 20 and 28 per session before you release. So actually, like an even better way to smoothen your quality assurance would be to do this before releasing and then rely on user metrics to refine it. So I'm saying it's a different methodology because what you're saying is like essentially you're measuring the in-game performance and I'm measuring the in-player performance. And there might be something that you can only see by taking one or two perspectives. So as I see it, is an implementation and an enhancement of what we can know about our game. Not by any chance saying just do biometric is going to be perfect. We actually do hardcore tests on top of this one, interviews, questionnaire, nothing that has to do with simple body responses. It integrated the information that we got. And I don't see why it cannot integrate also user metrics kind of information. Yeah. Nobody else? Please, questions? Okay. Thank you. It was a pleasure.